Math, science, engineering, physics, technology. Yes, that is correct. This is C4CW, casting 495 celebrities worldwide. I am one Sir Grove, host of this podcast. If you are true fans, then we 495 most certainly appreciate you. If you are not fans, well, then you probably don't like this show. And there really isn't anything I can do about it. That being stated, science, technology, engineering, mathematics, STEM. That's what we do. We do a lot of things. And it's a tradition with us, going back to the ancients before us, our predecessors, progenitors. And so we look at a lot of information. We evaluate it, assess it, analyze it. And I mean from a classical standpoint and modern standpoint, perspective. That is so true. From Newtonian mechanics up to today's quantum mechanics, theories of deeper space-time reality. Quantum Qubit, D-Wave company in Canada, having created what is said to be the world's first functional, working, commercially available quantum computer, dealing with Hugh Everett III, many worlds interpretation, model of the universe. Let's talk about Hugh Everett III's model of the universe. It used to be called an interpretation. I changed that. It's not an interpretation. It's been confirmed. That's right. Hugh Everett III's model of the universe, multiverse, superverse, interchangeably so, has in fact been confirmed. In fact, it is quite the consensus now in science, mathematics, that there are copies of us somewhere out here, right here, though not visible per se, with our human naked eyes, always, not always, and mostly not. Nonetheless, right here, less than 1 micron away, there's another us doing something in parallel. And this is true. Hugh Everett III figured this out, as did the ancients. Many of them, some of them, depending on your parallax view of the multiverse. And again, it is increasingly common in the world of physics, quantum mechanics, hyperphysics, that this is in fact a multiverse. And so as information changes, we are constantly analyzing that information to determine what is considered current and what is considered consensus. It is no longer unpopular to know and understand that there is not merely one reality. In fact, I remember when my math mentor, who's now a PhD, professor of mathematics at a major university, he shared with me the concept of manifolds, space-time manifolds. Now, I was in my very early 20s, back on the U.S. West Coast, north of Seattle, and he had attended the University of Washington in Seattle, and I was a guest invited to his graduation ceremony at Husky Stadium. And we, as high school graduates, college students, we would, as fellas, we would hang out, and we would have these kind of like game nights, poker nights, if you will. Nothing illegal, just card games and parlor games. And we'd sit around and have adult beverages, and some of our close friends and some extended friends would stop by, and our mentor, math mentor, who is now a professor, he would talk about such things as Zeno's paradox and quanta in terms of light energy, packets of light energy, wave duality, and the famous double slit experiment, Schrodinger's cat, and many other paradoxes and principles, concepts of mathematics. And it was all intriguing. Every bit of it was, every iota was indeed thoroughly, not just entertaining, but educational, informational, insightful, and most certainly intriguing, because I am someone who was an average math person. Just average math. Like anyone who's an average math person in high school, struggled with a handful of concepts like, this is difficult and challenging for me. How do I do this? What is the approach? And then later, I overcame that math anxiety. It was no more. And it began with the dissipation of said anxiety as a result of my mentor having shared with me the concept of space-time manifolds. Because in the Newtonian mechanics, if you will, kind of flat lander sense of it all, old school, Newton, simple, rudimentary, understanding at the time, yes, advanced for its time, but in the context of today, kind of limited, kind of finite, kind of simple mathematics. We're talking about Newtonian mechanics, like the apple falls from the tree, right? Just simple, basic X, Y, like axis with a little Z, but not too far beyond that. We're not talking about the fourth dimension per se, or the fifth dimension so much in terms of quantum mechanics and extra dimensions, hyper dimensions, special dimensions. No, we're talking about simple, flat surfaces, simple, basic mathematics and physics. So when it was brought to my attention, this concept, notion of curved space, I thought to myself, okay, right, this is what Einstein was talking about. Special relativity, general relativity, Einstein, Rosenbridge, Heisenberg, these types of principles. And so this book that he gave me to take a look at, that he imparted, it was an eye-opener, because inside that book, it talked about this concept of the Kaluza-Klein. Kaluza-Klein. And how the Kaluza-Klein is this special curvature of space-time. And that in the context of hyperdimensions, extra dimensions, multiple other alternate parallel universes, these Kaluza-Kleins, these constructs, they play a very key, important role in transdimensional, hyperdimensional mathematics physics, because they are, in fact, key components forming the gateways to these other universes. And within every Kaluza-Klein dimensional geometry is curled up another other hyperdimensional, as I indicated, transdimensional time spaces. So the Kaluza-Klein is not something that I was apprised of or taught anything about in high school. And most people to this day have never even heard of a Kaluza-Klein, ever. So the curling of space, the folding, twisting, warping, bending, distortion, in some respects, of space-time are important aspects of mathematics to explore. He also talked about Brownian motion. Brownian motion, particles within a certain volume of space, time, and how those particles will become diffuse and distributed. They will disperse and move about, bounce around, and how in relation to one another, that movement of particles is known as Brownian motion. And he would emphasize Brownian motion. He also talked a lot about Fourier analysis. Fourier analysis was also emphasized in relation to Brownian motion. And Euler, Poisson, the martingale, in terms of game theory, probability, trial spaces, probability spaces, trial spaces, different conditions, and taking place within the realm of probability probability spaces, trial spaces, different probabilities taking place within a set of data sets with their inherent, intrinsic probability spaces is what he discussed. So it was kind of sort of discrete in that it was a handful of topics. So, pun intended, he would discuss discrete mathematics, continuous random variables. He would discuss Brownian motion, as stated, Fourier analysis, stochastic processes, and it was very interesting, to say the least. Very, very interesting. So imagine you're someone who has little to no background in college university mathematics, which is where I was, along with my friends from childhood. And we would sit around and we would listen to these advanced topics of mathematics that were brought to us, presented to us by way of our friend from childhood and math mentor, who is now, again, a professor of mathematics. So that really was an eye-opener, very thought-provoking, and it paved the way for my matriculation, that is, entry into the field of mathematics. So we look at mathematics on a daily basis, my colleagues and I, my friends and I, and we study classical mathematics as well as modern mathematics and the contrast, juxtaposition, relationship between the two and the differences thereof. And we look at applied mathematics, technology, as stated, science, technology, engineering, mathematics. So not just math, but physics and electronics, electricity, electromagnetism, electromagnetic energy, that is, and all these different phenomena related to mathematics. You can call it general science, you can call it advanced science, you can call it advanced topics, refer to said fields as, and it is really a larger body of fields of knowledge where the basis for each and every respective field is the language of mathematics, if that makes sense. So that's where we are, studying math, remaining within the field of mathematics, because math is what we do on a daily, nightly basis, around the clock, 24/7, 365, looking for those patterns, looking for those trends, looking for those timelines. Hyperspace surveillance. Thanks for tuning in to another episode of C4CW, casting 495 celebrities worldwide.